Ready, Ross?
Ready?
What's today, Ross?
Draft day!
Draft day!
Raiders!
NFL draft is today.
Oh my
Oh
gosh!
my gosh, he is beyond. He's like insufferable. I just can't even.
You can, because I can. And you can too!
Oh my gosh. Okay. Go Raiders. Get good people in the draft. Get
Like my jersey?
I do like your jersey. And you like the football?
Like the football?
Phil Villapiano.
Signed.
An old Raiders person. And then, okay, Ross has to show off his jersey because
Check this out!
Derek Carr
Autographed!
Derek Carr signed Ross's jersey last year, 2 years ago?
2 years ago.
A couple years ago. The same time I asked Derek Carr if he knew Andrew Jackson, because Andrew Jackson and Derek Carr went to Fresno State together, and Andrew Jackson was my student.
Yeah,
He
baby.
sat in this same room where you guys sat.
Science!
And he knew Andrew, and he said, yeah, Andrew was a great guy. Yeah, okay, anyway. Yeah.
Nothing better than science and Raider football.
Science and Raiders football.
And you.
Oh, Ross, you're so sweet. Okay, so enough of that. Now we did this Raiders football. Now we can do the science part.
Like my Bose headset?
I like your Bose headset. Are you listening? Are you live streaming something right now?
That's science too.
That is science, yes. Yes, it is. Everything is science. Okay, so we're gonna start with the lab that you did yesterday, that you wrote up, and we're gonna go over the questions and your data, your results. So you should have your data table all filled out. That was your data table, all filled out. And then the graph, you could have done the graph on here. I did it on a separate piece of paper because I didn't like that little piece of paper, so that's how I did it. So the pencil is the hydrogen peroxide and yeast, and the pink pencil is vinegar and baking soda. So you can see the contrast between the one that increased in temperature and the one that decreased in temperature. So those were the graphs. Two different graphs on the same piece of paper, so you can compare and contrast them. Okay, so that was my graph. And then on the questions, it says examine the graph. I'm on the observe and analyze part here. It says number 3, analyze data. Examine the graph.
Yes.
When did the temperature change the most in each part of the investigation? And it looks like it changed the most. This one immediately went down. This one immediately went up. So within the first, what is that, first couple of minutes?
I counted every 30 seconds.
You did. That was perfect. And so it's like within the first couple of minutes is when the most change happened. And when did it change the least? Well, the least would be when the line kind of flattens out. See how it kind of flattens out down here?
Yes.
So after the first 2 minutes, it just kind of
Flattened out.
flattened out. Okay. Compare the temperature at the start of each process with the temperature after 5 minutes. How did the temperature changes compare? Okay, so at the start of the hydrogen peroxide and yeast, we had 16 degrees. I can look back over here at this.
Celsius.
I had 60, thank you, Celsius. Thank you, Ross. 16 degrees Celsius. At the end of the investigation, it was at 29. So it was a change of 13 degrees. However, it did go from 16 to 32. So the overall temperature change, the most it changed was by 16 degrees. It went from 16 to 32. So it got 16 degrees hotter, then it started to cool down. And then on the vinegar and baking soda, it started at 36. Remember, we had it in the hot water bath,
yes,
and we heated it up first?
Yes.
Okay. So we started it hotter,
Hot.
and then we brought it down, and the coolest it got was 20 degrees before it started to go up again. But I think that was because it was probably about getting to be about room temperature at that point.
Like me, room temperature.
Like you, room temperature. So 36 to 20, that's 16 degrees. Again, they both, the biggest change for both of them was 16 degrees. One went down 16 before it started going back up. One went up 16 before it started leveling off. So 16 degrees was how they compared. They were the same. Okay, conclusion questions on the back. It says conclude. Number 1, Classify, is the mixture of hydrogen peroxide and yeast endothermic or exothermic? So hydrogen peroxide and yeast, did it cool down or did it get hotter? It got hotter, so it is exothermic. Is the reaction between vinegar and baking soda endothermic or exothermic? Well, it got cooler, so it's endothermic. Provide evidence for your answers. Well, our evidence is our data. This is our evidence. The temperatures are our data.
We did a lab.
Yeah, we did it. Yeah, we showed it. Okay. Number 2, evaluate. Did you have any difficulties obtaining accurate measurements? Describe possible limitations or sources of error. Well, since you and I did it, of course, it was perfect, but there are some things that could go wrong and have gone wrong in the past. One thing that goes wrong, of course, is operator error when you actually do something wrong. You or your lab mates do something wrong. One of the things that goes wrong is somebody who's reading the thermometer doesn't know how to read the thermometer correctly, or they
Playing on their phone.
Or they're playing on their phone. Ooh. Or they read the Fahrenheit instead of the Celsius, and that makes everything go way out of whack. Another thing that happens is the thermometers sometimes, like it happened to me yesterday when I was working with a thermometer, when I was putting it away and putting all the materials away, the little thermometer thing slid down. So that would, the actual little thing that has the marker in it that shows what the temperature is, that little glass thing, it actually slid down on the scale. So it looked like everything was a lot colder, and actually it was just the little metal thing sliding down. The temperature wasn't changing. So that was equipment that was faulty. So there are other things that can go wrong. Sometimes people don't keep time accurately, but we know that we didn't do that because Ross would
30 seconds on the dot.
Yeah, he let me know too when it was 30 seconds. Okay,
That
so
surprised you.
what's that?
That surprised you. Went so fast.
It did. I know, every 30 seconds was like, oh, okay. I wasn't ready for that. I wasn't expecting it. But you kept me on task, Ross. Okay, and then question number 3. What does the reaction between baking soda and vinegar tell you about their bond energies? This is a good question. Because it got colder, it means that it takes more energy to rebond the atoms in the reaction than it did to break them apart, because the bonds need to take energy from their environment, and that makes it colder outside so that the bond energy can be applied to the atoms.
Yes.
That's why. And in an exothermic reaction, it's just the opposite. It takes more energy to break the bonds apart than it does to put them back together, so then there's excess energy, and that's why it gets hot.
Yes.
Okay.
Nicely explained.
Thank you. I do what I can. Okay, so that's the lab. And then the next thing we're going to do is just look quickly at the review packet. You have a test tomorrow, so I want to make sure everybody has good answers for this. So I think what I'm going to do is just flip through the pages and just show you the pages. Just hold the pages up so you can see them to see if you have good answers. There's one small catch. The pages you have are not exactly the same as the pages I have, but the questions are the same. So they're all in the same order and everything, but there might be extra stuff written on these pages. This is my answer key. You don't usually get to see this. You don't get to see this. But I write other things on here. I make other marks to remind myself to do things or to say different things. Anyway, so I'm just going to show you the pages. And this is page 1. That's what page 1 looks like. And here's page 2. They're not numbered the same either. This is page 2. And if I go too fast, you can always pause.
Pause.
Right? Yeah, 2. Okay. Page 3.
Pause. Kind of like my life. Virtual pause.
Page 4. Hope you can see that. Page 5. Page 6. Page 7.
How many?
16. Page 8. Page 9. Halfway there.
I'm fidgety.
Yeah. You're anxious about the draft.
Yes.
Page 10. Page 11. Page 12. Page 13. Page 14. Page 15.
Who are you?
Excuse me? Page 16. Okay. Are you talking to the workers out there now?
Yeah.
Okay. Yeah, there are a bunch of guys out there working now. They're starting to do the construction. So that's kind of exciting. There is a...
Making your school look so nice.
Yeah. Repairing the leaky roof on the gym, I hope. There is a mobile home on the blacktop right in the middle of the 8th grade court. So, yeah, that's interesting.
I go over there at night.
Do you go over there at night?
Check it out.
Check it out. Okay. Okay, so we did the review packet. That's that. We're going to revisit the focus question now. And the focus question was, how do we detect energy changes in chemical reactions? And you wrote this in your planner, or your planner. You wrote this in your science notebook a while ago when we started this. So now we're going to answer it. Let me get my notebook spot. Okay. How do we detect energy changes in chemical reactions? Okay, ready?
Ready.
Go.
Go.
Bonds
Bonds.
between atoms. Bonds between atoms break apart. And reform during chemical reactions. This bond energy is released or absorbed as heat. We can measure this. Transfer of energy. With the thermometer. Indicating if the reaction was exothermic giving off energy or endothermic. Absorbing. Okay, I must admit, there is one thing that I don't mind about this distance learning, and that's that when you are all here, I had to write this 5 times. Now that you're not here, 1 time. I only have to write it 1 time. Okay, but that's the only thing that I like And I don't even realize because I don't mind writing them. Okay, so let me read this one more time. How do we detect energy changes in chemical reactions? Bonds between atoms, that's bond energy. Bond energy. Bonds between atoms break apart and reform during chemical reactions. This bond energy is released or absorbed as heat. We can measure this transfer of energy with a thermometer, indicating if the reaction was exothermic, giving off energy, or endothermic, absorbing energy. Nice, okay? So that is our focus question. And you have one last thing to do, and that is the Chapter 9 vocabulary. This is on my website under worksheets, and it's got a front and a back. This will help you study for the test that you're taking tomorrow. Basically, what we're going to do tomorrow is we're going to correct this, and then you'll have the rest of the time to take your test. So that's all we have for today. So finish this for tomorrow, and I'll give you the answers to this tomorrow, and then you can take your test.
Awesome.
Awesome, possum. We're all done.
Are
Ready
we?
to rock and roll?
Yeah.
I think we're done, Ross. I think that's a wrap.
Who do you want in the draft?
And in the first round,
We select
the Oakland Raiders.
a wide receiver.
A wide receiver.
And we
And
have one more pick in the first round.
oh, and in the first round,
A linebacker.
the Oakland. I said Oakland Raiders, didn't I?
It's okay. We're still great. The greatness
The
always lives.
Las Vegas Raiders. Ah, no more season tickets for us.
Ah!
But we still have a Raider room.
It's pretty bad.
It's pretty bad, as in good. Yeah, we have a lot of Raider stuff in our house.
Okay, peace out. I gotta go.
Okay,
Bye.
gotta go. Bye.